And hello, welcome to this video. So in this video, just for the sake of showing another example, I have I have my unit converter here, but instead of using the regular functions and methods I did before, classes and object-oriented programming, I made sure to use dependency injection. So remember we learned about dependency injection in the last few videos. So here's another example where it's more complicated than just adding the price of a chicken burger. So let me explain my code to you. So let's go to program.cs. That's where we start injecting our dependencies. So I want you to pay attention to this part, and this is under my experimental branch. I may or may not change it in future, but as of today, the code looks like this. Okay, I'm adding a few scoped objects, okay, a few scoped services. Okay, remember services are just special classes which you add here, and they can be injected as dependencies into your page model. Okay, so what classes do I have? I have I-energy conversion, I have I-base unit conversion, and I have I-power converter. Okay, and then these are the following implementations of these interfaces. Okay, the interface I-energy conversion will be implemented by simple energy conversion. I-base unit conversion will be implemented by simple base unit conversion. I-power converter will be implemented by power conversion. So you might ask, okay, all right, remember when we do all these dependency things, we add scoped. This is what people mostly do. Okay, there's also add singleton, but we are not going to go into that just yet. But yeah, this is a slightly more complicated example. So let's quit this thing. Okay, so we saw the program.cs. So I assume you know, of course, some dependency injection, but yeah, here's the other one. Here's the other, what do you call that? Here is the other example. So let me open up the interfaces and implementations for you. ISI unit conversion.cs, simple SI unit conversion, and complex unit SI unit conversion.cs. Let me use a vsplit to open up two windows and bn to change. Okay, so well, let's take a look first at the base unit conversion classes. So here's my interface. Okay, my interface here is I change pounds. Okay, Americans like to use pounds rather than kilograms for food and everything in the supermarkets or in well, yeah, in the shopping centers or whatever. So they like to use pounds. Okay, so like 50 pounds versus 20 kg, something like that. So okay, pounds to kg and kg to pounds, these are two functions, okay, for their interface. So to implement interfaces, you remember we're just supposed to define inputs and define outputs. So the inputs here is pounds to kg, the input here is pound, and the output here is a double of type double, and it's going to give you the kg in pounds. Okay, and likewise unit conversion reverse, kg to gram, gram to kg, nothing too interesting there. Here is time conversion, seconds to hour, hour to seconds. So it's 1 hour has about 3,600 seconds, or exactly that. Okay, so this is a base unit conversion because in physics we like to talk about the 7 base units, and 3 of the most common base units are mass, length, and time, and then after that temperature, because we talk about energy and all these very commonly in engineering. So there's a length conversion, but I'll leave this for the future. I can do this for future, but there's also a temperature conversion, which currently only has Fahrenheit to Celsius and Celsius to Fahrenheit. Okay, how do I implement it? Okay, here is the simple base unit conversion. Okay, pounds to kg, kg to pounds, it's about 2.2 kg, 2.2 pounds per kg. Kg to grams, 1000 grams is 1 kg, quite obvious. Okay, and seconds to hour, hour to seconds, you just times or divide by 3600 respectively. And then Fahrenheit to Celsius and Celsius to Fahrenheit. Okay, this is a kind of a slightly more complicated, okay, but nonetheless it can be put into one simple equation, which I just typed out over here. Okay, a very simple equation. So that's what we have. Okay, and then next thing we have is energy conversion. You have this interface here called I-energy conversion, and then this implementation called simple energy conversion. Now, of course, in real classes, you might not want to squeeze so many. In real life, you might not want to squeeze so many classes into one C# program. But well, I figured that unit conversion is kind of close enough. I can do all sorts of unit conversion, and I want to squeeze them into this SI unit conversion file. Okay, so all right, simple SI unit conversion. All right. Okay, so the interface looks like this. You have a British thermal units or BTUs to joule, and then joules to BTU. Okay, joules to kilocalorie and kilocalorie to joules. Okay, so and then the implementation is as such. We have I started over here because we have these interfaces: joule to BTU, BTU to joule, kilocalorie to joule, and forth. Okay, so everything goes through the SI unit, which is joule. I hope you know all this. This is just unit conversion example. If your physics should be okay. Okay, so I actually make a specific heat capacity of water in SI units. So that is joules per kg, joules per kilogram. Is it per degree C? Okay, I think it should be 4184, not 4.184. I need to change this here. Okay, specific heat capacity of water. Okay, 4.184 joules per gram per Kelvin. Okay, so that's not in SI units. SI units is joules per kg per Kelvin. So I need to change this, and later I'll change the things. Okay, so here is the here's how we convert BTU to joules and back. Okay, times a factor of 1055. Okay, there are lots more decimal places than that, but I just choose to omit them. Okay, and then joules to kilocalorie and back, you just times or divide by 4184. Okay, that's the simple way of doing it. But there's also a more complex base unit conversion. Okay, so here is the complex base unit conversion which I'm doing. Okay, what's so different between the two? If you take a look at pounds to kg, I just define as kg equals pounds divided by 2.20462. Whereas the kg to pounds here, I did a more complicated way. Instead of multiplying by 2.20462, I actually called this function pounds to kg, and then I call this function here, and then I just put 1 pound. Okay, 1 pound. Okay, 1 pound is how many kg, then you divide this. So it's basically 1 divided by this number, which is 2.2 roughly, and then you'll get the same effect. But why am I doing this? I'm just saying that you can have two different ways of doing the same thing. Yeah, so this of course is like the more complicated way. That's why I call it complex base unit conversion. Kg to gram and gram to kg, I did the same thing. Seconds to hour, hour to seconds, I did the same thing. But for Fahrenheit and temperature degrees C, I had to manually type out the formula right here, because I cannot just divide one by the other. Okay, it's a little bit more complicated than that because of the plus and minus 32 degree Fahrenheit. Okay, so what else do we have here? Okay, I have a specific heat of water in SI units. Why do I have this here? Because I go how I calculate BTU in joules and joules in BTU is to use the definition. Okay, one British thermal unit is the energy required to heat 1 pound mass of water by 1 degrees Fahrenheit. So I need to calculate the 1 pound mass of water in kg and 1 degree Fahrenheit in Celsius to get the 1 BTU equivalent in joules. Okay, so 1 pound mass in kg is, well, I will need to have this dependency injected, base unit conversion, pound mass to kg. So, okay, base unit conversion, pound mass to kg, and you can see I have a dependency injection mechanism here. I base unit conversion, which is the interface, will have the implementation base unit conversion. Okay, so this is where I inject my dependency objects. Okay, so after that, I have 1 Fahrenheit in degree C, just times 5/9. Okay, or 5/9 degree C is actually 1 Fahrenheit of difference. Okay, 1 BTU in joules is the specific heat of water in SI units times 1 pound mass in kg, so that is about 0.44 kg times 509 degrees C. Then I return 1 BTU in joules. So I assume you know all these calculations if you do engineering work a lot, so this is very common. Okay, BTU per joules is just the reverse of this. Okay, BTU to joules will actually make use of this 1 BTU in joules conversion factor. Okay, it will multiply how many BTUs by how many joules per BTU. Yeah, so this is how many joules per BTU. Okay, 1 BTU in joules. I call it 1 BTU in joules. And then joules to BTU, this thing will be reversed. Okay, I'll divide by this. So the conversion factor is like manually calculated every time. So this function here will be called by this function whenever you do unit conversion. So that's why I call it the complicated way. But it will give you a slightly more accurate answer, I think. Depends on how many decimal places I give it. And likewise, 1 kilocalorie in joules. 1 kilocalorie or 1 calorie is actually energy required to heat 1 kg of water by 1 degree C. So 1 calorie in joules is just the specific heat of water in SI units. And then 1 kilocalorie in joules is just that divided by 1000. And then okay, of course the unit of energy you often see in your Coca-Cola, your soft drinks, your sodas. Okay, Coca-Cola is trademark. I'm so sorry. Okay, never mind. Yeah, you have Fanta or whatever. Okay, so those things, you see those labels, they give you this energy content in calories. That's calorie with a capital C. Okay, instead of a small c, it's a capital C, and that's actually kilocalories. But kilocalories sounds very much like you're putting on so much weight. So they rather give you the calorie with a capital C. Yeah, that's how sometimes people like to represent kilocalories. Okay, so that, yeah. So joules to kilocalories is kcal equals to joule divided by 1 kcal in joules. Same idea of a conversion factor right here. Okay, you can go check that out yourself. So these are two different implementation of how I do this energy conversion and base unit conversion. Okay, so I can just change this program.cs to use whichever dependency I liked, either simple energy conversion or simple base unit conversion. And then I use those things to do the power conversion right there. Okay, so the power conversion will actually take in the base unit conversion as its dependency. Alright. Okay. What? Okay, so I have not talked about the power conversion models. That model will be in pages. Okay, I should actually shift all the model files to this models folder, but I chose not to. The power conversion is actually in this unit conversion.cs. Okay, so I have my unit conversion class. Okay, our unit conversion namespace. Okay, this is the namespace unit conversion, and okay, my power conversion actually is an implementation of this iPower converter. What do you call it? Interface. Okay, iPower converter interface. And where did I set the interface? I can't even remember. Okay, for me is the iUnitConversion.cs. Yeah, iUnitConversion.cs will contain the interfaces. So you can see interface I temperature converter, you have C to F, F to C, back and forth. I power converter will have this BTU per watts and watts to BTU per hour, or BTU per hour to watts and watts to BTU per hour over there. And what this power converter will do, how this is implemented. Okay, I'll use the proper terms now. How this is implemented is over here. Okay, I have two dependencies actually primed for injection. So there's I energy conversion underscore energy conversion, I base unit conversion underscore base unit conversion. You kind of know the drill now. So I make two private variables and we type them as the interface, and I base energy conversion and I base unit conversion. We use energy conversion and base unit conversion, and we use this constructor injection to inject in these dependencies, and then we set those private variables or private attributes as these dependencies. And then what do we do? Okay, next thing we do is to start using these dependencies. So for example, BTU per hour to watts. Okay, I want to first calculate what is 1 BTU in joules and what is 1 hour in seconds. So I use that to start to change BTU to joules, because 1 watt is one okay, I think I make a mistake here. Okay, 1 watt per hour, that doesn't make sense. 1 joule per hour. Okay, so I want to calculate 1 BTU per hour. We first convert the 1 BTU to joules per hour, and then we convert the time thing to how many watts, 1 hour in seconds. So there's that conversion factor thingy down there that I'm trying to do here. It's a little bit hard to write it out in the comments, but if you've done unit conversion before, this should be quite straightforward. Okay, so how I do my 1 BTU per hour in watts conversion factor, it is 1 BTU in joules divided by 1 hour in how many seconds. In other words, 1055 divided by 3600. Okay, so I make two doubles over here. One is the BTU per hour in watts, and then I make a watts variable, and then I give the user input BTU per hour right here, BTU per hour. Then I multiply by how many watts is 1 BTU per hour, and I return it. Okay, and then for the watts to BTU per hour, what I do is that I just call this function, and then I just invert it. Okay, I'll call this function, and then I'll invert it. Okay, so that the code is very clean. I don't need to write all this again and then be error prone. Okay, so this is my power converter. Okay, what goes on behind, and I shoved everything into this test page. So you can look at test page .cs html.cs, or I'll just put star down here, and then I will split the screen and change, Control WW, and I'll change. Okay, so where's my dependency injection? Okay, my dependency injection is, oh, not even here. Okay, here I have the manual dependency injection. I have not changed the dependency injection to the automated version, which I wanted before. Did I even git pull? I think this is an old version. Okay. Or maybe it's in test page 2. I actually put it in test page 2. Because test page 1, I have the old version of dependency injection, the manual version. Okay, this is the manual version of dependency injection, where I manually make the simple energy conversion classes. And then I just put it into the power conversion class object manually. So this is manual dependency injection. But I think maybe in test page 2, I have something a little bit better. Okay, test page 2.cs html. Okay, so I made a copy of the test page from test page 1 to test page 2. I showed you in very early videos how that is supposed to be done. So let's v-split this thing. I hope I have my code right. Okay, yes. So you see, over here I have my proper dependency injection. So what I put in? Base unit conversion, energy unit conversion, power converter. Okay, so these are the interfaces, and these are the attributes. The underscore base unit conversion, power conversion, and energy conversion. And then I use constructor injection right here. I type the objects as the interface. Okay, the objects we put in as the interface, and then we will just put everything in here. right? So this is the dependency injection part, where, well, in the page constructor, this is the page constructor because the page model name is test page 2 model, test page 2 model, okay, test page number 2 model, not test page 2 model, if you know what I mean. So test page number 2, the model will perform dependency injection based on the constructor injection method, I mean the way we are doing things. And then what happens when we convert BTU per hour? So I actually have a property which is bound called BTU per hour. I have a get and set methods here. Alright, so this is a property, and I bind the property to a button. Okay, so we've gone through how to do that before. And the button is called convert BTU per hour. Okay, so the view data here will be the BTU per hour that the user puts in here, this BTU per hour property. And then the what's result is this power conversion, BTU per hour to watts. So this is the function within that dependency, which is power conversion. And then what do? I give this BTU per hour, put in the BTU per hour user input, and then this becomes the watt result. The watts result will be pumped into the view data, and the view data will be, as you can see right here, the view data will be displayed right here under this table item here. Result is at BTU per hour is equals to watts result watts. Okay, so how do we do it? I use the input ASP for BTU per hour, and that will automatically bind this to this button, or this input to this property, using the bind property method right here. And remember, with bind property, we will need to implement this system component model data annotations. We need to use this namespace in order to use this bind property thingy here. Okay, so that's the ASP for BTU per hour. Then we have validation, of course, that we talked about before. And then what do we have? A submit button. The submit button will use the ASP page handler, convert BTU per hour, which is going to activate this post, because it's going to do an on post thing and convert BTU per hour. Okay, right, and it will have all these validation things, so that if I enter nonsense here like ABCDE, okay, ABCDE will then not be a valid value for BTU per hour, right? So at least the web page, well, it's not the most pretty of web pages, but it tells you if something is wrong, and that's very important. Okay, so 1, 2, 3, 4, 5, and then I need to not use the enter, but it will just say here 1, 2, 3, 4, 5 BTU per hour is this many watts. Of course, I can do round off and everything, but that's not the point of this video. This video is just to show you another example of dependency injection. Oh wow, what is this? BTU per hour to watts. Okay, so 1 BTU per hour, 0.293 watts. Oops, let me put my browser page back. There you go. There you go. There you go. Yes. So 1 BTU per hour is how many watts? Okay, 0.293055555. Okay, so well, it's not exactly the same, because there are some round off errors and everything, but otherwise it's pretty good. It's a pretty good working. It's working pretty well. Yeah, and the moment I can demonstrate just restarting in program.cs, and then I want to open up the models complex unit conversion.cs. I will vsplit. Okay, what am I doing here? I want to change the dependencies that are being injected, and then reload the web page. Okay, so I can change this from simple energy conversion here. I can change this to complex energy conversion, and then what I can do, it will resend. I can change the 1 BTU per hour to watts, and you see here nothing actually changes, because hot reload does not reload all your services. So to reload your services, what you have to do is to shut down your server and then start it up again. Okay, that's the only way that you will be able to reload your services. And then only then and only then, hot reload will be able to work. Okay, so you'll let it build its DLL and it will start. And of course, the more dependencies and the more complicated the more dependencies and the more complicated things that you put into the web page, the longer it takes to build. Okay, but let's take a look. 1 BTU per hour to watts we convert. Okay, you will see that again it's slightly different because we use a different approach to calculating that unit conversion. And again, there may be some round off errors or stuff like that, but the point is that no matter what is the decimal places we have successfully integrated all the learning we have done in the last 20-ish videos. How to do submit buttons, how to perform validation, how to make new web pages, how to do dependency injection at multiple levels, the so-called manual way and the not so the more automatic way where we inject services using a scoped object or scoped service. Alright, so that's it. I guess this is our final example before we want to move on to the next things. So so this is a more proper, more complicated example of dependency injection. I hope this again was helpful to reinforce some of the concepts of dependency injection that we did in the last few videos. And yeah, it certainly helps me to prepare these classes and then do videos on them. It helps my learning and I hope it helps your journey as well. Okay, thanks for watching. I'll see you again. Bye-bye.